that symmetry means? Symmetry means identical. It means same. Whenever, and the line of symmetry means the line which divides the one shape into two equal parts. You can see this is the heart shape object, and this M is a line. This M is a line which is the line of symmetry, and this line of symmetry divides this heart shape object into two equal halves. You can see the equal halves is there, and this equal halves means everything. Area is also same, and the shape is also same. Look, say everything is similar, no? So shape is also same, and the area is also same, and the line is also same. So everything is similar. That means that it is the identical parts. These two are the identical. Identical means same parts, same, similar. So this is the line of symmetry that we will be studying today. And you can see this heart shape object can also be divided into two identical parts. This tree-like object can also be divided into two identical parts. Butterfly can also be divided into two equal half. So you can see each of the figure have equal half. That means equal part can be constructed by making a straight line. So these figures are called symmetrical figures. Understand? Those figures which can be divided equally into two equal halves, they are known as the symmetrical figures. But those figures, okay, which cannot be divided into two equal halves, they are known as asymmetrical. Okay. And another is the line which divides the figure into two halves is called axis of symmetry. So here you can see this M was the line which divided this butterfly into two equal parts, no? So this is known as the axis of symmetry. This M line is known as the axis of symmetry, and the axis of symmetry is like a mirror line. So it's like a mirror line. What happens whenever we go to the mirror, and if we see ourselves, then we see that exactly our copy we see exactly in the mirror, no? So that is how this axis of symmetry reflects. It reflects exactly the symmetrical part. Suppose if this is a mirror and if this is an object, if you just go in front of the mirror and you can see the similar object at the backward side of this M axis. So this is known as the axis of symmetry. And many of the letters of the alphabet, English alphabet, are also symmetrical. Now you can see here this, if A is divided, then also it will have the equal halves in both of the sides. If B is also divided like this, but sometimes we need to know that how the axis of symmetry exists, okay? Exists, because sometimes it will be the vertical. This one is the vertical, okay, and this one is the horizontal axis. This is horizontal axis. This is the vertical axis. So vertical axis, if we do the vertical symmetrical line, draw the vertical symmetrical line in this A alphabet, then it will be also symmetrical. If we draw horizontal in B, then also it will be symmetrical. C also symmetrical, E, and every other alphabet are symmetrical. So now we will talk about one line of symmetry and the two line of symmetry, three line of symmetry, four line of symmetry. What does that mean? So now understand, okay? Whenever an object will be divided from one line only, then it is known as one line of symmetrical object. Okay, those objects which can be divided by one line of symmetry only, then it is known as one line of symmetry. This butterfly this heart can be also divided by one part only. If we divide, suppose if we divide like this in a horizontal pattern, then will it be the symmetry? Will it be the symmetrical object? No, it won't be the symmetrical object. That's why this one is only the one line of symmetry. And if we talk about this butterfly also, this is also one line of symmetry, because if we cut horizontally, then also it cannot be divided. It cannot be called as a symmetrical object. And this isosceles triangle also same. If we divide it horizontally, then we cannot say that it is a symmetrical. So only the one line of symmetry is heart shape object, butterfly, like butterfly shape, like isosceles triangle. These are the one line of symmetry. Now if we talk about the two line of symmetry, you can see yux, the letter yux. This yux can be divided. Now you can see from the upward side also, if we divide, then the same pattern, look, like a half x would be there, half x would be there. And if we divide the horizontal pattern also, half x would be there, look, only the half x would be there in both of the side. That's why this is known as the two lines of symmetry, because both the lines, line 1 and line 2, they, if they will be cutting the if they will divide this object, this letter x, but also the equal halves can be formed. Similarly, now in rectangles also, what we can see, if we divide by letter 1, then also the equal halves can be formed. If we divide by the horizontal pattern, then also the equal halves in the upward side and the equal halves in the downward side can be formed. That's why this is also the two line of symmetry. Now if we talk about h also is the same. You can see h is also same, I is also same. Okay, here I is not written, but I is also the same, because if we turn this h into the upward side, it becomes I, no? That's why I is also similar. That is also the two line of symmetry. One can be divided, line 1 will divide, then you will see the half portion and another half portion. If you divide L by L2 in a horizontal manner, then also you will see half I type of figure you can see, and half inverted I type of figure you will be seeing here. And another you can see now, figures having line of symmetry, three lines of symmetry. So how the three lines can be derived? Since we know that first of all there will be the vertical, that is the y-axis, and another is the horizontal. Horizontal can also be done. And now this type of axis that you are seeing, no, bango type, right? This is the bango type, that line of symmetry. This we call it as a diagonal. Okay, diagonal line of symmetry. So when this diagonal line of symmetry is there, then this can be also considered as the three lines of symmetry when this can be divided from the three different lines. You can see one line is here, I1, another line is here, I2, another line is here, I3. If we divide by I3, but also we will see the two equal parts. If we divide it by I2, then also you will see the two equal parts. If we divide it by I1, then also you will see two equal parts. So that's why it is a equilateral triangle is also the figure having three lines of symmetry. Now what about the square? One line, two line, three line. So it is also which symmetry? Is it having only the three lines? It's having the four lines of symmetry. So what you need to understand now, not only the diagonal, from both of the diagonal part as well as in the horizontal part as well as in the vertical part also, it can be divided. If you see this figure, okay, compare this figure. It was diagonally, it was possible. In vertical manner also it was possible. But if we divide horizontally, then it would be divided equally. This triangle will be divided? No, it won't be.
No.
Yes, very good. That's why the four line of symmetry is a square. Okay, now next. Next you can see figures having infinite lines of symmetry. Now whenever the question will ask you which is the figure that will have the infinite lines of symmetry, then you have to say it's a circle, because circle can be divided at any part. Suppose you see, suppose this I2. If I2 will divide this circle, then you will see semicircle here and another part also semicircle will be there. If it will be divided horizontally, then also half semicircle upward side, half semicircle downward side. That's why from every part all the lines can equally divide this circle. That's why this is having the infinite. Infinite meaning, the meaning of infinite is so many that is countless. Ganna nasakine. Okay. this is the figure having no lines of symmetry. Now you can see this figure, this parallelogram. No, whenever we try to divide by the vertical line, but also this won't have the same equal parts. If we divide by horizontal manner also, it won't have the same equal parts. So this is a parallelogram having no lines of symmetry, and the scale and triangle also, it doesn't have the same line of symmetry. Okay.
Excuse me, teacher.
Yes.
Let parallelogram, if we'll divide it diagonally, then it will be half, no?
Yes, exactly. It is said to be half, but it's not being parallelogram. It is said to have no lines of symmetry. These figures is said to have no lines of symmetry. It is considered so.
Excuse me, teacher.
Yes.
I have done it all.
Everything done?
Yes, teacher.
Okay. Okay. Now you can see, draw the line of symmetry as many as you can. So how many lines of symmetry you can draw here? Just you have to divide it into the equal parts. Okay. So this can be drawn. If we divide from the vertical, yes, if we divide from the vertical, then only it would have the same equal parts. What about this? Yes, vertical only. This?
One.
Okay, now everyone draw this picture and draw the line of symmetry as much as you can. D number. Draw and show it.
Good drawing.
Yes. Okay, you found it too? Is it two lines of symmetry here?
Yes, teacher.
Yes,
One
teacher.
from the vertical and another from the horizontal, right?
Yes,
And this
teacher.
is a square, no? This is a square. So what happens with a square? Can we divide it diagonally?
Yes, teacher.
Can we
Yes,
divide it
teacher.
diagonally from another part?
Yes, teacher.
Yes,
And
teacher.
vertically and horizontally?
Yes, teacher.
Yes, teacher.
So it has four lines of symmetry. Okay, like this you have to do all different questions, and in this question number 2, here it is said that this is the line of
Question number 1, and it will be only one line of symmetry.
yes. And this is the scalene, it doesn't have the line of symmetry. And this is the isosceles. This is the isosceles, no?
Okay.
Yeah.
It has only one.
Okay, now you can see the shape of object is given, and here the dotted line is given. This is the axis of symmetry. Okay, this all are the axis of symmetry. So what you need to do, you need to draw the similar type of figure in another part also.
B.
Yeah.
B.
Yeah. You have to just draw it. Okay, you have to draw it in the and here also you have to draw the similar type of figure. Here also same.
Christmas tree.
Yes. Okay, like that you have to draw.
And card symbol.
Yes. So this one only drawing is there, so you can do it. There won't be problem. Now find the number of lines of symmetries in each of the following figures. So what can be the symmetry here? What can be the lines of symmetry?
One.
Here,
one.
one.
Four.
Okay.
Here.
Five.
Here it would be
Five.
4. Here it would be
Finite.
4. Because this is a square.
B number is finite.
No, it won't be infinite because this is a semicircle. You can see this is a semicircle.
It's not infinite.
So it will be 2.
Okay. So like that. Okay, now question number 4. Once you see, draw the any two figures which has no line of symmetry. Can you do it?
Yes, it's a scalene and
Parallelogram.
parallelogram.
Okay. Now all the students please draw the two figures which has 3 lines